So what was it? It was a vector 4? I think it has to be a tuple. I think it's like 1.0, 1.0, 1.0, then the opacity. So also have a 1.0. Okay, so I loaded in the model view matrix, which it's not actually using. It only uses view matrix. Wait, I should look at the quadratic, the shader for the quadratic Bezier curves. I love how this one mixes the naming. It has like uniforms prefixed with U. Then it has attributes that aren't prefixed with A. Love that. Anyway, this code will use the model view matrix. I think this is going to need these two. Model view matrix and the projection matrix. I'm feeding in the model view matrix here, projection matrix here. I'll copy the transformation right from this. Camera space. So I'm going to take the position, multiply the model view matrix. This will bring it into world coordinates. Now this will bring it into the camera coordinates. And the projection matrix will bring it into the screen coordinates. Then I can output the GL position. That looks right. Then I don't think I need these precision directives. I just need to output the U material color or whatever. Okay, I'm just gonna see what this does. Time to YOLO it. Manim chords shader. So I'm giving it the model view matrix, giving it the projection matrix, giving it the positions, giving it the color. Okay. Attribute is deprecated. Use in or out instead. That would explain why the other thing was using in and out. Okay. GL frag color is deprecated after version 120. This is why you don't copy shaders from P5. I guess you just use frag underscore color. And the position is still GL underscore position. Okay. Undefined variable frag color. That doesn't make much sense to me because I thought I was outputting frag color. I guess I have to explicitly say that I'm outputting it. Here. Okay. Well, now it's just not appearing. So let's see. The coordinates look like they make sense. The model view and projection matrices. And this should be all white when it appears. So why would nothing appear here? And I am doing render. and I am doing render. Guess the next thing to try... Actually, there are a few things to try. The A position. Maybe I can just... Well, for one thing, I'll take out these precision directives, since I don't think I need those. And I don't. And as for getting it to appear in the frame, I'm going to try not using the two matrices, the projection matrices. Hope that's how you do comments. And instead, just write to the GL position directly. It must be like this to do comments. Guess that would make more sense. And I'll say GL position just equals the A position. Okay, let's see if that works. Key error model v matrix. That actually doesn't make sense to me. Why would that happen? Shaded up by 185. Oh, I just didn't save this. Still doesn't appear. Why would it not appear? What I'm probably gonna have to do, what I'll eventually end up doing, is starting from the test shader and like over and over changing one thing. Oh! I never actually did any of the rendering commands. It's like down here. I set all the attributes. So basically all of this. So let me see. The vertex buffer object is a buffer from the attributes. That makes sense. The array object is this vertex buffer object. There's only one attribute. Render with triangles. Okay, see if this works any better. And it does. That's great. So now, if I project these using the model view matrix and the projection matrix, instead of writing directly to the GL position, I think, darn, I was hoping, oh, I didn't save this. It disappeared. Okay, so that's a different bug. So if you're not too familiar with shaders, the model view matrix and projection matrix, the purpose of multiplying by these is to map the coordinates, because initially the coordinates are always in this space where like this is -1, 1. I should probably just try to pause this or whatever. This is -1, 1. This is the origin. This is 1, -1. But in Manim space, the coordinates are different. And the way to translate the points from the space that OpenGL understands, which is basically -1 to +1, from Manim coordinates, is to use these matrices. And I remembered actually, I didn't even set the matrices, so maybe I should do that first. Nice. Nice. So this is in Manim coordinates. I have -1, -1, 0. the origin, then 1, -1, and it is being projected in Manim coordinates. Have -1, -1, 0, the origin, then 1, -1, and it is being projected in Manim coordinates now. And if I change that color, that should change too. I just take out the green. Okay, cool, cool, cool. So that's great, actually. That means I can render with shaders. And with the proper matrices. Okay, that's a lot of progress on its own. More than you probably think it is. Because I remember the first time I was dealing with these, this was a nightmare to get these shaders running. So I think what I'm going to do is change these into the naming convention that basically that Grant uses, and then commit it. Because this namespace, this with the the U prepended and the camel case or whatever, that's from P5. And we don't actually need it. So I'm just going to change this to invert. Make sure that still works. And it doesn't. Great. What are they called? Uniforms. I'm mostly copying the naming convention from shaders that Grant wrote. But I don't know all of them. Where are the uniforms? Oh, I guess he just had nothing prepending the uniforms. I think I prepended with a U underscore. Yeah. Let's save that. Okay. Same thing. And this. Great. And the color, which I think can just be, let's call it U color. Great. Nice, nice, nice. So now I'm going to commit this because I actually managed to get shaders running on this. What I really want to do is have a mobject. A mobject where I can just do like M equals ShaderMobject. And it would be like vert equals some file. And like frag. And like uniforms equals whatever, attributes equals whatever. That would be super nice, and I could just like add this. but not yet. Okay, I think I'm just going to commit this how it is. And take out the import community colors. I'm actually, oh. I'm actually, oh, I know why this isn't that much code. I didn't add the new files. I have to add shader.py. Actually, let me trim down shader.py. Because the only things that work. Actually, I don't know. Maybe the quad shader works. I guess I won't trim it down then. Why is this freezing? Did I do something weird? Dot. Okay. I want to add the test shaders. I'll just add this and I'll add the example code. And I want to switch to another branch for this. Call it ShaderMobject. So what is it that you're programming? That is a great question that I might be able to answer with a command, but maybe not. So I've actually heard from people that sometimes they don't see the blurb that appears from !Manim. So can you see that? Like, I can see it, but I'm not sure if you can, or if anyone else can. Okay, you can. Great. I don't know what was going on before, because I was like trying to tell someone about it, and they just couldn't see that at all. But yeah, that's what it is. And basically, we're trying to make it a lot easier to render math. And so if you pick this up and you install it and stuff, you'll be able to do simple animations like this. If you're looking at some more, you can like do really easy math diagrams, things like this, you know, the deal. Pretty much anything that if you're teaching a math lecture and you're drawing stuff on a blackboard all the time, then it's basically to help you animate all that stuff that you'd normally be writing. Now we're in a kind of funny place in this project because we're overhauling all of the rendering code so that it will work with OpenGL instead of working with Cairo, which Cairo is this super old way of rendering. And I mean, it gets the job done. It's actually simpler too, but it's just super slow and annoying, and it should be an OpenGL. So I'm trying to get this running in OpenGL pretty much. And for the most part, it is. Like, this rendering is being done in OpenGL, which is why I can run shaders on it directly. But I'd like to do a bit more than that. So what I think I'm gonna do now is there must be a GL frag position or something I can read from the fragment shader. Does this rely on latex intermediate files in an SVG? Yes, it does. For better or for worse, it will render LaTeX PDFs to a PDF, then like convert those PDFs into LaTeX PDFs to a PDF, then like convert those PDFs into SVGs, and then like use vector graphics to render those. Okay. Bezier. So what I've been doing here, how was I getting this distance? I guess it was just interpolating the endpoints. What I'm trying to do now is find a way within the fragment shader to get the coordinates in 3D space. And if I can do that, then I should be able to do really nice animations like, not this. I should be able to do really nice animations, like the ones from Shader Toy, I think. Or maybe not Shader Toy. Let me see. If I look at a random shader here, I feel like a lot of these will require intermediate files. This one is only shapes. There's gotta be some of these that aren't wildly complicated. It'd probably take a lot of effort to port this over. Wasn't there something like Python, OpenGL, or like scientific computing this? Cube, points, etc. Doing something like this, I think, should be doable. Or any of these, I hope. Okay, so this is the fragment shader. And you can read in GL frag chord. Is that what it is? The answer is there is no interpolate. Wait. How things are interpolated between vertices knowing there's only one vertex. There is no interpolation. If we want to know the position of a fragment relatively to the center, we have to find it. However, GLFrag chord gives us the absolute coordinate of the fragment in window coordinates. Subtracting the center from this coordinate will give us the relative position of the fragment from which we can compute the distance to the outer border of the point. Okay, so that's super confusing. I think I'd have to rely on something like that, though. Let me see. Here's what I want to do. Class some other shader. I'll just call it my shader or whatever. I'll just call this like design, something like that. Uh-oh. There. if I can bring in the model view matrix and the projection matrix. And at first, I'm just gonna copy these actually. I just call this design. And I meant for that to be on the top. And .frag. And I'll just copy in the Manim chords ones. And this fragment shader. And this fragment shader. So if I run this, well, first of all, if I put this here, and import this, and run it, I should see that triangle again. Now if I make that triangle larger, close that, close that. Wait, here, okay. So I make this larger. I can make this negative. Was it like, is it called like screen X radius or something? Or is it just X radius? I think it's like frame X radius. I should probably know my own config. Okay, so yeah, that is what it is. So I can make this cover the whole screen, I think. Or I can make this cover half of the screen. If I put the vertices at negative this, and then negative config. It sounds like a great project, thanks. Negative Y radius. What I'm hoping is that I can sort of trick this into having a full canvas from which I can see the output of shaders, of arbitrary shaders. So then I'll put this to positive X radius, positive Y radius. So now I'm covering half the screen, which is the most I can do with one triangle. So I could add another triangle. Right now, I'm going to try to modulate this color somehow. Shader sign color. Oh, this is a good website for this, the Book of Shaders. Their first example is really complicated for some reason. Come on, give me something easy. Why does the first example have like arctans? Even just to write a triangle. Okay, all of these are incredibly difficult. Way harder than I thought they would be. Wait, maybe the color. I think that's probably about as easy as we're gonna get. Maybe I can port this shader to run it in Manim. It's using glfrag chord. Color. Use a map loader. This makes me shiver. Yeah, this is about as complicated as graphics programming gets. Like, what does the fract function even do? Thanks. Okay, so here's what I'm gonna do. Put this on the second screen. And by second screen, I mean the same screen. Open this. This is mostly only using the fragment shader. Okay, and I'm gonna try to just copy this. Although I don't have the resolution vector. Whatever.